Hello everyone, let's solve the problem minimum time to complete trips. You are given an array time where time of I denotes the time taken by the ith bus to complete one trip. Okay, each bus can take multiple trips successively, that is, the next trip can start immediately after completing the current trip. Also, each bus operates independently, that is, the trips of one bus do not influence the trips of any other bus. It means that all the buses can run simultaneously. Okay, you are also given an integer total trips which denotes the number of trips all buses should make in total. Return the minimum time required for all buses to complete at least total trips. So let's talk about the first example. We have been given this time array. Okay, now what does that mean? The ith bus takes the time of ith time, right? So bus 1 takes 1 second to complete one trip, bus 2 takes 2 seconds, and bus 3 takes 3 seconds to complete one trip. So if we start our journey, okay, all buses would start to run together, right? So we are starting from 0. Now at first second, how much will they cover? First second is elapsed, bus 1 will complete one trip, but bus 2 is yet to complete one trip because it takes 2 seconds for bus 2 to complete one trip. Similarly, bus 3 is also not done. So at first second, this is the condition. Now if we consider 2 seconds, bus 1 will complete 2 trips and bus 2 will complete finally one trip. But bus 3 is still yet to complete his trip, right? That would be 0. Finally at the third second, bus 1 will complete 3 trips. Bus 2 will complete still one trip. He needs one more second to complete another trip, right? And bus 3 will finally complete one trip. So how many trips did they all complete in total? 3 plus 1 that is 5, right? Which is the total number of trips we have to make at least. So 3 seconds is our answer. Fine. Now let's take this new example. At time equals to 1, this bus will complete one trip, 0 0 0 and 0. At t equals to 2 seconds, this bus will complete two trips. This will complete one, this will complete still 0, and this will complete 1, and this will be 0. Okay, at t equals to 3 seconds, this bus will complete 3, this bus will complete still 1, this bus will complete one trip finally, and this bus will complete still 1. At t equals to 4 seconds, this bus will complete 4 trips, this bus will complete finally 2 trips, this bus will complete 2 trips, and this bus will complete 2 trips, and this will still remain 0. Okay, now how many trips have we completed? 6, 7, 8, 9, 10. We have completed 10 trips already. Okay, so we don't want to make any new trips. We don't want to consume any more time. Still this bus is yet to complete its trip, but we have already achieved our result, right? In this case it was still yet to be achieved, right? 3 plus 1 is 4, 5, 6, 7, right? So 4 is our answer. Now the thing is, we took 4 seconds to finally complete at least 8 trips, right? If we consider say 5 seconds, we will still be able to complete 8 trips. Say if we take 100 seconds, we will still be able to complete 8 trips, right? That would be the number of trips at that situation we will complete would be way higher than 8, right? But we need at least 8 trips, right? So 4 is doing our work. In that case 4 seconds is satisfying us, right? But if we consider 3 seconds, we are not able to complete 8 trips. We are needing 4 trips at least to complete 8 trips, right? We are taking 10 trips in that case. Let's assume that these are the times each of the buses take to complete one trip, and we need to complete one trip. Okay, in that case, in the first second itself, bus 1 will complete one trip, these will remain 0. We are done. Say these are our buses, the time our buses take. We need to complete 5 trips. At first second, 0 0, one trip, 0 0. At 2 seconds, 0 0, two trips, 0 and 0. At 3 seconds, 0 0 3 0 0. At 4 seconds, 0 0 4 0 0. And finally at 5th second, 0 0 5 0 0. So 5 seconds is our answer. Who completed this task? The bus with the minimum amount of time, right? So what did we do in all these examples? We tried with 1 second, we tried with 2 seconds, we tried with 3 seconds, then 4, 5, dot 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 dot. As long as we are not able to complete our required number of trips, we are trying, right? And as already discussed, let's say 3 is our optimal amount of time. Okay, at 3 seconds we are able to complete at least required number of trips, total trips, right? But if we try using 4 seconds, then also we are going to complete. If we try using 5 seconds, then also we are going to complete. If we try with 100 seconds, still we are going to complete. Same for, let's say, 1000 seconds, right? But out of these potential answers, we need the minimum, isn't it? So can we take a hint from this? We are trying to search our optimal answer in this range of potential answers, isn't it? So can we apply a binary search here? Definitely we can, right? This is a sorted sequence of our potential answers, right? We try with a, say, random, say this one, and we see if we are able to satisfy, that is complete the given total trips. If we can try for a better answer, right? We see that we are still able to satisfy, we are still able to complete the total trips. We again try to improvise our amount of time. Let's say we take this and we see that no, we are not able to complete our trips, then we have to increase our time. So isn't it binary search? Pretty obvious, right? Now if we are applying a binary search, we need our upper bound and lower bound, right? Lower bound and upper bound. So what is our lower bound and upper bound going to be? Our lower bound is going to be the minimum amount of time a single bus takes in our time array, isn't it? That's the minimum amount of time required at least, otherwise we won't be able to complete a single trip, right? Say minimum amount of time a bus takes is 2, so we have to complete at least 2 seconds to complete one trip, right? So that's going to be our minimum in our time array. Say it's 1 second, so 1 second is going to be our lower bound, our minimum in the time array. Now what about the upper bound? We can take a really large value, right? But instead of doing that, let's do something else. In this example, we saw that we took at max 5 seconds to complete all the trips, right? What is that at max 5 seconds? That is the minimum time into the total number of trips. So our lower bound is going to be 1 in this case, and upper bound is going to be 5. Why 1? We need at least 1 second to complete one trip, right? And 5, that is the max amount of time that is required to complete all the trips, right? Don't bother about the other bus times, right? This one is doing our work, so our answer is going to lie in this range. Let's say in our first example 1, 2 and 3, our answer was 3, right? Our trip time was 5, total trips was 5. Minimum time is going to be 1, lower bound, at least 1 second to complete one trip, and 5 seconds at max to complete 5 trips by this one only, by our most efficient bus, isn't it? Our answer is going to lie in this range, that is 3, lies in between, isn't it? So our lower bound is going to be the minimum in the time array, and upper bound is going to be upper bound is going to be minimum into total time. Okay, you can still take a very large value, but let's make it more specific. That would still work. Okay, so it's totally your call. So what is our algorithm going to be? We have our lower bound and upper bound. Let's call it high. We will, as usual, calculate our mid, and we will try to complete trips with this mid. What is this mid? This mid is a assumed number of seconds, right? We will see that with these number of seconds, m seconds, is it possible to complete all the trips? If it is possible, we will try for a better m, or we will try for a lesser m value. Okay, that is by reducing our search space. That okay, with m seconds we are able to complete our total trips. Let's say we can do it in lesser time. Otherwise, if we are not able to complete total trips in m seconds, we will have to increase our time, right? We will increase our time, that is mid plus 1, and in this case mid minus 1, right? So pretty simple. Okay, let's see the code now. So this is our code. We initialize our low, that is the minimum in our time array, right? You can do a for loop and compute the min. I have used my shortcut. Okay, what is our high? Low into total trips, we saw that. And let's have a variable answer. Okay, so we are going to do a binary search on our potential answers in the range of our potential answers. So as usual, while low is less than equals to high, compute this mid. Okay, now let's see if with this assumed number of seconds, can we complete at least total trips? For that we have created a method, right? Long trips equals to 0, trips plus equals to given time by t. Now what is it? Let's say this is our time array and we have assumed a time, let's say 6. Okay, this is our mid value, just assume. So how many trips are we going to complete using 6 seconds? Bus 1 is going to complete 6 by 1, that is 6 trips. Bus 2 is going to complete 6 by 2, that is 3 trips. And bus 3 is going to complete 6 by 3, that is 2 trips, right? Basic mathematics. So we see that yes, we are able to complete at least our given amount of trips, and we will like to decrease our time and see if we can complete trips, right? So that's what we are doing by dividing it with each element. Okay, plus equals to, because we are adding this, right? Return the trips. Okay, now if this is greater equals to our total trips, that means we are able to complete, right, our given total trips. So in that case we will try to look for a better solution, right? We will decrease our search space and we will try with a lesser mid value, and see if we are still able to complete our total trips or not. Okay, so for in the meantime we will keep this potential answer recorded in our, okay, answer variable, right? Because this mid was able to complete our total trips, right? So this can be an answer, isn't it? So we will keep it recorded. If we are able to still satisfy, right, if we are still able to complete our total trips in lesser time, we will record that one in future. Otherwise, if our time is falling short, then we will increase our assumed time, right? We will move to a greater search space, isn't it? And at the end we will return our answer. Okay, now let's do a quick dry run of our solution. Okay, low is going to be the minimum 1 and high is going to be minimum into total trips, that is 5. Okay, now what is mid? Mid is 5 plus 1 6 by 2, that is 3. Okay, let's see, in 3 seconds can we complete 5 trips? Let's see, in 3 seconds bus 1 is going to complete 3 trips, bus 2 is going to complete 1 trip, bus 3 is going to complete 1 trip. How many trips in total? 5 trips. Okay, we can. How many seconds we took? 3 seconds. Okay, this can be an answer. Let's keep it with ourselves. Okay, now let's look for a better solution, lesser time. In that case we will decrease our high. High becomes mid minus 1, that is 2. Now what is our new mid? New mid is going to be 2 plus 1 3 by 2, that is 1. Okay, in 1 second let's see, bus 1 completes 1 trip, bus 2 is not able to complete any trip. Same for bus 3, we could complete only 1 trip. No, this is not going to be our answer. We need more seconds, we need more time, right? Increase our low. So low becomes mid plus 1, that is 2. What is new mid? Low plus high by 2, 2 plus 2 4 by 2, that is 2. In 2 seconds let's see, bus 1 completes 2 trips, bus 2 completes 1 trip, bus 3 completes 0 trip. How many trips did we complete? 3 trips. Still not able to complete. So this is not going to be an answer. We need to increase our time. So increase low. Low becomes mid plus 1, mid is 2, low becomes 3. Now low is 3, high is 2. Our condition low less equals to high is broken, right? That's where we stop. So this was our answer that we recorded last. This is going to be our best possible time and we returned this. Okay, now let's talk about the time complexity. Initially we are computing our minimum, right, from our array. This is going to cost us a big of n time. Okay, also if you do a normal for loop, it's also going to cost you a big of n time, right? So time complexity is big of n. Now we are doing a binary search. Binary search on whom? Binary search on a range, right? Range of potential answers, low and high, isn't it? So what is this range? This range is high minus low. So let's call this range as k. Okay, just for assumption. So it's a binary search, right? So a big O of log k, isn't it? And at each step we are calling this trips with given time method. Now in this method we are traversing our time array, right, which is another big O of n, isn't it? So into n, now which is ultimately big O of n log k. You can call anything instead of k, you can say n log range or whatever. So ultimately this is going to be our time complexity. And what about space? we are not using any extra space, so a constant, right? So yeah, that's all about this problem. I hope I made it clear, right? But if you have any kind of doubt, you are welcome to put that up in the comment section, okay? And other than that, if you like this video, do hit the like button and share this video and subscribe to my channel, and I will see you in the next video. Bye bye.